Hello, Dobry den. I'm Ilmari Heikkinen. I'm here to talk about offline, or as your world used to be. And the summary of, I'm going to give a small introduction of myself. I'm working at the Google UK office as a Chrome developer programs engineer, which is basically a fancy name for a person who writes demos, talks, articles, documentation, and then does talks like this. So what we are going to talk today is about using the offline features in HTML5 to store static content, to store dynamic content, for storing binary data, and syncing your application status with the server, and increasing your application performance by using offline features. Before HTML5 came along, we had some offline features. You've got cookies, you can store a small string of text in a cookie, maybe 4K or so. Flash storage gets you more storage, but you need Flash for that. There's Internet Explorer user data from IE versions 5 and up, which works pretty much the same way as the local storage API these days. Then you've got Google Gears, another plugin-based solution for storing data. Dojo Storage is a library to abstract over all this complexity and give you a single API to using the offline features. Then there's also a hack for sort of a storing a small string of text within the same browser window. So you just set window name to some string, and it will stay the same between when you're navigating to different pages on that window. But it's a terrible hack. So why would you want to use offline features? Maybe because you're offline. So in an airplane, on a road trip, on a deserted island, or maybe you have a really flaky connection. You go to a cafe, you're driving around in a car, you go to the subway. The cell phone connection may not be the ultimate in that situation. Or maybe you just want to avoid downloading some data from the network. So for performance reasons, keep the data on the client. And it also consolidates this concept where you have an app that you download, and that's it. You don't need network for dealing with the app anymore, except for syncing data with the server. So first off, we'll talk about storing static content. So static content is about storing the files that you download as part of your page. Images, HTML files, JavaScript, style sheets. And app cache is designed for that. App cache lets you control what data to store on the client and for how long, or for what to do with it. So it works by adding this manifest attribute to your HTML file. And it has, the manifest file is a text file which consists of different sections. So you've got the cache section for files that you want to store in the cache. Then you've got network section for files that you don't want to store in the cache. And fallback for things that you want to store in the cache, but if network fails, get them from the cache. So cache, you put everything that you want to keep in the cache. Fallback, put something there if you want to download it from the network, if network is available. And network for things that you don't want to put in the cache. So the way app cache checks if it should consult the cache for a file, if a network prefix matches, if you've got here you've got network /login HTML, so any file that begins with /login HTML is fetched from the network. And if the cache has an exact match, that is, you have a file name and the full file name is in the cache, then it's downloaded. Then it's not downloaded, but it's cached and it's gotten from the cache on the next go. If the fallback section has a prefix match, then we try to fetch it from the network first. And if that fails, consult the local cache. And if you have a star in the network section, then any other file should be downloaded from the network and not cached. So manifest only works for sub-resources of the page. So you need to have a script or an image or a style sheet or an XML5 TP request from the site to the server to get something cached. So you need to load it manually first to get it cached. When you have frames and windows, they look in the caches for the same origin. So basically, the cache works on origin policy. And when you have a network match, it doesn't consult the cache. Fallback matches must wait until the network fails before it goes to the disk cache and checks it and uses the version there. So some gotchas. If you have an HTML document with the app cache attribute set, it's going to be cached. If you have a 404 on any of the URLs on your page in the cache, nothing is cached. If you have syntax errors in the manifest file, nothing is cached. And to update the files that you have, so if you have photo.png and you replace it with another photo.png, not changing the file name, if you want to reload it, you must update the cache manifest to force the reload. Since if it's a cached resource, it's just going to get it from the file cache all the time. When you do update the manifest, it first updates just the manifest, and then on the second reload, it actually updates the files. These and more facts about the app cache can be found from appcachefacts.info. It's a really useful site. It's got all these gotchas and things that you need to keep in mind when using app cache. A very useful feature. So some tips for using the app cache. Manifest, you want to disable server-side caching of that, because if you have server-side caching on the manifest, then things get a bit hairy. If the manifest is cached in the browser's cache, then you need to figure out how to force the reload using the HTTP caching stuff, and that sounds a bit painful. Easy way to force the refreshes to rev the manifest is to put a version number comment on top of the manifest and then just increment the number in that. When you change the manifest, just by incrementing the number in the comments, it forces a refresh. When you have application cache events, you could log them to the console. Helps with debugging. And if you're using file URIs, they don't really work for testing. So it's got the same thing as with XML5 CTP request. If you do a request to file URI, you most likely get a security error. So try to run a local server, either put an Apache server running somewhere or use Python-m simple HTTP server to run a really simple server. Here's a workaround for the load twice thing. So we're listening for an update ready event on the page. When we have an update ready, we can reload the page to get the new content. Okay, moving on, dynamic content. So first off, we are going to talk about web storage. Web storage is for storing unstructured data, strings. So this is basically for storing simple bits of data, like the high score in a game or something like that. The same kinds of things that you would use cookies for, but this is all happening in the client side, so you get no HTTP requests. The second part is about IndexedDB and WebSQL, the database engines for the client. And you can use them to store structured data, put data in tables, handle transactions. So first off, web storage. Local storage is the first part of web storage. And local storage is for storing simple key value stuff. So you have a string key here, and you set that key to some other string. So this basically works like a regular JavaScript object that is just persisted between page reloads. So the API has 4 methods. You've got set, get, remove, and clear. And if you're using local storage, you can there's actually a really simple way to use it. So you can just do local storage and use it like a regular JavaScript object. And that's all you need to do to use local storage. Now, when I reload the page, I can get foo, and it should be set to bar. So this is super simple. The one gotcha about this is that local storage API is synchronous. So when you set an item, when you read an item, there's a potential that it's going to hit the disk, and that's going to insert something like a 17 millisecond delay in the middle of your frame loop or whatever. So you don't really want to use this in interactive parts. So at page load time, page exit time, that's a decent time to use local storage. Then there's session storage, the second part of web storage API. It's the same thing as local storage, but it's just for the session. So it lasts as long as the browser is open. Opening a page in a new window or a tab starts a new session. If you want to do something that stays within the window, like form progression, saving some form progress data, it's great for that. And the storage APIs store only strings. So if you want to store something more complex, use JSON. JSON stringify to turn a JavaScript object into a string, and JSON parse to turn a stringified JSON into a JavaScript object. Here we have a simple example. We just insert some text here, GDD Praha 2011. Save it. Okay, it's saved. It should be available now. Okay, and this is really 4 lines of code. Just listen to the key up event on the form and change the value local storage item and change the timestamp to match the current timestamp. And the timestamp is just used for this little piece of text here. Second is structured data, IndexedDB. IndexedDB is a web database. And what you do with that is you have a database connection that you open a transaction on. You've got an object store there, and then you get a cursor to that and a query that. So basically, you've got an index, and that's something that speeds up retrieval of data. Without an index, you just go through all the items in the data one by one, and that's pretty slow. So with an index, you can skip around, or you can, if you have a hash table index, you can just go to the hash table key. Then you've got a cursor. When you query data from the index, you get a result set of data, the items that match, and the cursor is just for going over all those results in the result set. So IndexedDB is in Chrome, it's in Firefox. Other vendors have indicated an intention to support it, and you need to do the whole vendor prefix dance to use it. For mobile devices, WebSQL is the better choice because mobile Safari supports it, and mobile Android supports it as well. Or you can use one of the abstraction libraries to use it. So here's a small example with IndexedDB. We open the database, do a query do a transaction on that, get the object store, and iterate over it. So if I try to do something here, it will fail, I would think. Oh, there is an object store already. So it creates a key value pair to the object store that I can edit. If I set the key to a new value, I get a new key in the object store. And if I try to do this without the object store, it complains. So we need to create one first before we can operate on that. OK, so that's for dynamic data, structured data, binary data, files. So binary data is about saving files to your file system. And now in Chrome, we've got the file system API. A file system API gives you a nice little subdirectory on your hard disk that you can use for the page. So for the domain, you request a new file system, tell it if you want it to be persistent or just for this session, how many bytes you need storage, what to do. And this is an asynchronous API, so you got the init, so you got success callbacks and error callbacks. So here's a small demo. It creates a new file, creates a new file system, and then to the root directory, creates a new file called logFileText. It's got all these usual native operating system file style properties to the file, like is it a file? Yes, it is a file. What its name is what we wanted it to be. What's the path? And then you've got remove, copy, move, get the parent directory. If you want to do some operations on the content of the file, you need to get the file entry, the file object for the file entry. But there is also create writer, which gives you a direct file writer to the file. So here, what's happening is that I'm just handling the drop events on a div to go through all the files dropped on that div and creating a new file. Exclusive means that it's going to create a new file, or if the file already exists, it's going to error out. So create a new file for each of the files dropped, create a writer for that file, and write the dropped contents into the file. So it duplicates files dropped onto the div. Then, if you want to reference a file in the file system, you can use the new file system URLs, which are like file system colon the domain name, then if it's the temporary file system or the persistent file system, and the file name there. And you can use those for image source or for anything that takes a URL, basically. So you can put your JavaScript there, you can put your images there, and load them from the local file system. If you have the file system URL, resolve local file system URL lets you get to the actual file object from that. So, synchronizing data between the client and the server. So the goal here is to keep the client synced with the data on the server and vice versa. So when you have static files on the server that you are updating and you want the client to get the new version of them when they change, use fallback in the app cache. So you can get the files if you have network. If you don't have network, use the cached versions. Then for XML HTTP requests and when you're getting data, put the data into one of the web storage APIs or the IndexedDB or store it somewhere, and then use that to fill in your JavaScript objects. And when you have network available, you can use the network versions. When you don't, use the offline versions. When you're doing XHR calls, then just store the contents of all the calls, then it's easier to reuse. And manifests and fallback files you can update with a hidden iframe. Check in the iframe if the manifest has changed, if there's an update ready. And if there is, then reload. OK, one way to make data synchronization easier is to, instead of having each of your windows in the application having this chunk of data synchronization logic that's going to do all the network stuff, you put it all into a web worker. So now you've got a shared web worker between the windows, and that web worker is now going to be your data store. So when you have a network request, you ask the data store, okay, can you get me this file? The data store then communicates with the server, or if you're online, then it gives you the offline data. And this way, you can keep all your windows in sync. So when you get network data, when you get new data, the worker tells all the windows that, okay, we've updated the data, so update your views. And when a window has something new that it wants to put in the data store, it tells the data store, and the data store can broadcast that to the rest of the windows. And here is another nice feature for offline applications. Navigator.online lets you a simple property of the Navigator object that lets you know if you're online or not. And you also have events on the window object, online and offline events for when you go online or offline. Here's a small demo of that. So now we're online. And if I turn airport off, what should happen is that we go offline. And to test the other way around, I'm going to turn airport back on. Oh, it works. So again, this is like this is terrible because now I have to go back to the beginning of the presentation and go through all the slides again. Small bug in the presentation. So this is what 5 lines, 10 lines of code gets you online offline feature. Very nice. Then you can use the offline features to increase app performance. Keep data on the client. So use a web storage instead of cookies. That way you can avoid the HTTP request with the cookies. Use client-side databases for storing database-like data instead of doing server requests. So you can do something like load in a client-side copy of the database, do your operations on that, and then send to the server, send what's changed. For cache manifests, you can use them also for getting very fine-grained control over the caching happening on your web page. So it's not just for offline apps. With File System API, you can put the images that you use, all the other files that you use, you can put them in the file system, you can edit them there, you can then send just the finished version back to the server if you need to. And there are some nice offline features in the Chrome developer tools, which I will try to show now. So in the resources pane, you have all the different local storage. We should have something there. Okay, we've got the foo and the text input values. Session storage, nothing there, I'm afraid. Do we have any cookies? We have a cookie. Okay, this is probably something from Apache. And in application cache, nothing. So this is not a very offline presentation for an offline presentation. Okay, support. So this is the support matrix for these features. Local storage, session storage, very well supported, IE versions 8 and up. IndexedDB is in, as told, Firefox and Chrome. App cache, it's pretty well supported. Only IE doesn't support it. WebSQL is in Safari and in Chrome and Opera, but not in Firefox and not in IE either. And the file system API is Chrome only. And there is this nice site, caniuse.com, that shows you what features you can use. So PNG alpha transparency is not going to work in IE6, but there's a workaround, and so on. So this has all sorts of HTML features. You can check what is supported and what is not. On mobile, the story is pretty much the same. Local storage and session storage are supported on pretty much every platform. IndexedDB is only in Firefox at the moment. App Cache is, again, it's in everything but the Windows mobile browser. WebSQL is in the WebKit paste and Opera. File System API is available in the Android browser version 3 and up. And there's mobilehtml5.org, which has a similar feature matrix for mobile HTML5 features. Really useful for developers. So the amount of data that you can store is, for web pages, it's 5 megabytes. The local storage 2.5 megabyte limit is from WebKit-based browser storing UTF-16 strings, so a character is actually 2 bytes. So you can store 2.5 megabytes of characters. For IndexedDB, App Cache, WebSQL, File System API, the limit is 5 megabytes. But if you create a Chrome Web Store application and put a manifest on that, you can ask for unlimited storage. So if you need to store 100 megabyte files, then you could create a Chrome Web Store application for that purpose. You can request and you can request status of the quota. Check how much of the storage you are using WebKit storage info, WebKit specific feature. You can also ask for some amount of quota. If you want more quota, package your apps. It's really pretty easy. AppMater gives you a single form that you just fill in, and oh, that goes to a wrong place. And you fill in the form, and it gives you a packaged web app for your website. And when you get this zip back, you can open the application file, go inside it, open the manifest file, the manifest.json, and then add unlimited storage for the permissions. So here we have a manifest, which has the app name and blah, blah, blah. And then you've got permissions and unlimited storage. You want this to get unlimited storage, offline enabled. So here are some offline applications. One is SpringPad. I think I've got SpringPad installed actually. So the last time I tried this, I think it actually, the SpringPad server crashed. So I hope it's going to work this time around. But this is actually a really nice sort of note-taking application. So you take your notes in the browser. You can take them online, or you can also use it offline. And when you go back online, it syncs all the notes that you've taken. It syncs with the server. Okay, there we go. Let's get started. So I'm going to create a notebook, GDD 2011. Okay. And now we have a new notebook, and we are online at the moment. So I'll create a new note. Type in some stuff. And now I am going to go offline. So turn airports off and add some stuff. Okay, so now I've saved it and I'm offline. So no server connection available. I'm going to close this window and try it again. So this is the offline mode. And I go and I've got the offline node saved here. Now I can turn airport back on and it will sync this edited node with the server. That's cool. So okay. So if you want to use these storage API features, use one of the polyfill libraries for papering over all the differences, like storage polyfill, session storage. There's a bunch of these. This is by the Yahoo UI team, so it might be well kept. And there's also Stash and Launcher. Launcher, I think, is pretty popular. And now there's a book about the HTML5 file system API by one of my coworkers, Eric Beidelman, plug. It's about using the HTML5 file system API, as the name says. So okay, I think we're done for the day. Thank you.